Hello everyone, welcome to this talk within the Things conference. My name is Ektor Sotiropoulos. I am product manager for medium voltage and GIS surge arrestor with Hitachi ABB power grids. This talk is about the application of LoRaWAN sensors in power system components, and in particular, I will be introducing the wireless monitor for surge arresters. Here you can see the content of the talk, what is a surge arrestor and why do we need it. Then I will introduce the product in question, the wireless monitor for surge arrestor. Then we will discuss about some technical characteristics of the product, the communication principles that it follows, as well as the data and the way that this data is presented to the user. Then we will have a look at some installation examples which will lead into the animation video, which summarizes the most important in short for this application. Surge arresters are electrical equipment which have the sole goal to protect other equipment against lightning and switching over voltages. In the picture, you can see three surge arresters. They are these components that have the strange rings at their top. Surge arresters are commonly installed in substations, transformers, cable terminations, or even along the transmission lines. The metal oxide resistor, or simply the MO, is the core of surge arresters, a ceramic block with extremely nonlinear characteristics that is particularly important for the overvoltage protection. These metal oxide resistors are practically insulating at normal operation and become highly conductive at higher voltages, thus limiting overvoltage surges. Measuring the surges and their intensity provides useful information about the electrical network and its overvoltage stress due to atmospheric discharges and switching overvoltages. Additionally, the measuring of the leakage current through the surge arrestor provides important information regarding the condition of the surge arrestor. There are several devices in the market providing such information, none of which, though, utilizes LoRa communication and is fully wireless. After this short introduction on what a surge arrestor and its monitoring is, I have the joy to introduce you the wireless monitor for surge arrestor. This device measures the surge and leakage current through high and medium voltage arresters. It also records ambient temperature and humidity. Wireless communication is provided via LoRaWAN, a low-power wide area network operated by many major telecommunication service providers. Proprietary communication infrastructure is not a prerequisite for this application. The device is solar and battery powered, having a low energy consumption. Therefore, no auxiliary power source is required, and the long battery lifetime can be ensured over 5 years. All data and trends can be accessed and displayed on a web-based interface. Easy to access from everywhere, hardware and operating system independent. The web interface can be hosted in the cloud or on a local server. The main technical characteristics are shown on this slide. The peak of the discharge current, as well as its timestamp, are recorded and transmitted immediately after they occur. This current measurement ranges from 100 amps to 100,000 amps. The total leakage current is measured every hour, and the daily average is sent once per day. The current ranges from 50 microamps to 10 milliamps RMS value. Similarly, ambient temperature and humidity are measured every hour, and their average transmitted daily, similarly to the current, with a range from -40 degrees to 85. And for the humidity from 0 to 100 degrees. From 0 to 100%. The LoRaWAN wireless connectivity can reach 10 kilometers in open ground, line of sight. Communication is done on the 868 megahertz band for Europe and 915 megahertz band for North America. Of course, private gateways can also be used. The monitor measures the total leakage current flowing through the surge arrestor, as we mentioned before. This leakage current is composed of two components: the current through the core of the surge arrestor, its metal oxide varistors, and this current consists of a capacitive part and a resistive part. In addition to this current, the creepage current flowing on the arrestor surface, depending on the humidity, pollution level, and housing material of the arrestor. And then the monitor measures the sum of these currents. The total current through the arrestor can increase in case of a deterioration of the arrestor, for example, moisture ingress in the varistors. The leakage current of a surge arrestor at nominal system voltage is typically between 50 microamps and a few milliamps. An increase in voltage over time will indicate a deteriorated arrestor. Moving to a perhaps more interesting part for this conference, this schematic shows in a simple way the principle of communication between the device and the user. A surge arrestor can be installed, as we said earlier, in the substation or along the transmission line. The monitor will transmit the recorded data via the LoRaWAN gateway, and from there, via TCP/IP to the LoRa server. From there, the data can be accessed by a web-based application and shown to the user via a cloud-based interface, being accessible from everywhere, from anywhere. A mobile device, such as a smartphone or the office computer, can be used. In short, the unique features of this application include the long-range connectivity given by the LoRa communication, the low power consumption required for this communication, which can ensure a longer lifetime for the batteries, longer standalone time. In addition, the utilization of public networks, and also thanks to the principles of operation of LoRa, many devices can be connected through the same node. Last but not least, the need for minimal infrastructure as well as low subscription cost make it a low-cost solution for introducing IoT monitors for power system components. All data are displayed on a web-based server, which can be hosted by DE Connect Core from Hitachi ABB, combined with other services, predictive analytics, etc., or by any other web service provider, or by a company's web server, and then it can be also integrated to asset performance management systems, APMs. Displayed data and pages are configurable, of course. In this example on the right, we can see data in a tabular form and also as a chart. We can see the last values of the discharge current and leakage currents. We can see a trend and the latest value for the temperature, the humidity, the leakage current. Well, access to this data is location, hardware, and operating system independent. In addition, specific events can trigger remote alerts in the form of an email or SMS. A special event can be a leakage current above a specific value, or a discharge current above a specific value. In these pictures, we can see some examples of installation of the wireless monitor for surge arrestor. We have some pilot installations which are in operation in Switzerland, in Slovenia, and in Norway. On the left-hand side, you can see the 3 arrestors of the 3 phases and the 3 monitors at the ground connection of each arrestor. On the right-hand side, we have an example how the wireless monitor can be easily retrofitted and replace a previous analog solution, a conventional type. In this last slide, I have included the web page of the product for your reference before we move to the animation video where the most important aspects are summarized in short. It was a pleasure to be here with you virtually. Of course, I remain at your disposal for any questions or comments. Thank you very much for your attention.
The condition of electrical assets is one of the key factors in ensuring constant and reliable power supply. Electrical equipment on the transmission line and at the substation is often subject to harsh conditions such as lightning strikes. Hitachi ABB power grid surge arresters protect these equipment from lightning and switching over voltages that may cause the breakdown of critical electrical assets. Introducing the wireless monitor for surge arrestor. It empowers customers with fast, real-time information to further help them ensure the reliability of their substations and electrical equipment. A device enabled for the Internet of Things captures critical information like surge and leakage current, as well as temperature and humidity. The data is transmitted via wireless IoT network called LoRaWAN to the cloud, and thus becomes easily available for managing maintenance of the equipment. A plug-and-play solution that requires no additional cabling or external power supply makes it ideal for retrofits and remote installations. The wireless monitor for surge arrestor enables digital monitoring too and enhances the management and maintenance of assets. Hitachi ABB Power Grids, powering good for sustainable energy.